In this video, we continue our look at infinite series. Specifically, we're going to do a few more examples which employ the divergence test. Let's quickly restate what the divergence test is. If the limit as n goes to infinity of the nth term of any series equals some finite number c that is not 0, or if that limit does not exist, or is infinity or negative infinity, then the series diverges. One side note that's important is if you get a limit that does equal 0, the divergence test is inconclusive. All right, so let's take a look at the following example. Apply the divergence test to the following series. State your result. We are looking at the infinite series n equals 1 to infinity of the cosine of 1 over n. And we want to know, does this series diverge? Well, let's write down this series. What is it? It is the infinite series n equals 1 to infinity of the cosine of 1 over n. And if we're going to apply the divergence test, that means we simply have to look at the nth term of this series and we ask the question, what is the limit as n goes to infinity of the cosine of 1 over n? Well, let's see. 1 over n, that's what gets affected as n goes to infinity. In fact, as n goes to infinity, this becomes 1 over an infinitely large number. And so 1 over infinity heads to what? It heads to 0. So that tells me that the limit as n goes to infinity actually goes to the cosine of 0. And what is the cosine of 0? The cosine of 0 is 1. And what does that help us do? Well, the nth term divergence test, remember, says that if this limit does not equal 0, the series diverges. That's what the nth term divergence test tells us. The series diverges. That was really simple. So let's write our conclusion. All right, so the series diverges because the limit of the nth term cosine of 1 over n equals 1, which is not 0. And thus, the nth term, or simply the divergence test, or the nth term divergence test applies. The nth term divergence test tells us that if the limit is not 0, the series will diverge. Awesome. All right, the next example. Apply the divergence test to the following series. State your result. We want the infinite series n equals 1 to infinity of 2n over e to the 2n plus 1. So we have the infinite series of 2n over e to the 2n plus 1. All right, we're specifically asked to use the divergence test, and that tells us we want to look at the nth term of this series and see what happens. So we take the nth term, which is 2n over e to the 2n plus 1, and we're going to take a limit as n goes to infinity. So what happens here? Let's see. Well, as n goes to infinity, 2n goes to infinity, correct? And e to the 2n goes to infinity. The plus 1 is negligent, right? And so what do we get? We get an indeterminate form here. Indeterminate form, right? Indeterminate, always have trouble with that word, form. Infinity over infinity. And what do we do when we have a limit with an indeterminate form, infinity over infinity? Well, one of the easiest ways to deal with this particular limit would be to use L'Hopital's rule. And so let's apply L'Hopital's rule. Do you remember? We take the derivative on top and we take the derivative on the bottom. So here we go. We're going to take the limit as n goes to infinity. Derivative on the top. The derivative of 2n is just 2. The derivative of e to the 2n plus 1. Well, let's see. That's the derivative of e to the 2n, which is e to the 2n times the derivative of 2n, which is applying the chain rule, which just gives me 2 in front. And the derivative of plus 1 is 0. So it looks to me like the derivative of 2n is 2, and the derivative of e to the 2n plus 1 is just 2e to the 2n. Ha, ha, ha. Ha, ha, ha. Do you see what's going on here? Those 2's cancel, which gives us a 1 left over on top, right? So really, all we're looking at is we are looking at the limit as n goes to infinity of 1 over e to the 2n. Oh yeah, here we go. And now what happens? As n goes to infinity, we already know that this goes to infinity on the bottom. 1 divided by anything that grows infinitely large gives us a limit of 0. So how does that apply? Divergence test says we have to get a limit that's not 0. So what happens if we get a limit that's 0? Well, the divergence test doesn't tell us. This is inconclusive. Maybe inconclusive. Maybe this series converges. Maybe it diverges. Not sure. What we're going to have to do is wait until we get a few more tests in our toolbox, and then we can talk about whether this kind of a series diverges or converges. But for now, the nth term divergence test is inconclusive. So, the nth term divergence test is inconclusive. The nth term divergence test, or simply the divergence test, is inconclusive. We do not yet know if this series converges or diverges. As I mentioned, we'll have to wait till we get some more tools in order to make this determination. Okay, let's take a look at our last example together. Apply the divergence test to the following series. State your result. This is the infinite series n equals 1 to infinity of 4n cubed over n squared plus 5n plus 6. All right. What is our series? Our series is actually a rational expression. It's a polynomial on top of a polynomial. 4n cubed over n squared plus 5n plus 6. And applying the divergence test tells us we want to look at the nth term of this series, which is 4n cubed over n squared plus 5n, and we want to look at the behavior as n goes to infinity. Do you see what happens right away? If we have a rational expression and we're taking a limit as n goes to infinity, the only two terms that apply really are the highest degree terms. So we look at the highest degree in the numerator and the highest degree in the denominator. And so this limit will be equivalent to the limit as n goes to infinity of 4n cubed over n squared. Can do a little math simplification. N squared divides into n cubed and leaves us with n. And so that tells me that really I'm looking at the limit as n goes to infinity of 4n over 1, or just 4n. As n goes to infinity, what happens? This whole thing goes to infinity. That's a good result for us with the divergence test, because remember, the divergence test is all about, does this limit equal 0? Do those terms get smaller and smaller and smaller? They don't. They diverge. They get bigger and bigger and bigger. That tells us that our series is going to be diverging, right? And so let's state that result. The series diverges by the nth term divergence test. Or if we like, by the divergence test. And if I wanted to add one more clarifying statement, I would say since the limit as n goes to infinity of 4n cubed over n squared plus 5n plus 6 is infinity, which is not 0. So that ends our discussion of the divergence test. Next, we're going to look at another test to add to our toolbox called the integral test.